Hi and welcome to our 6th video on complex numbers. And this is our 3rd video on polar form, and this is a part of our maths module. So in our last video we went through some series and we proved how z can be given in terms of r by e raised to the I theta. Now I've given you 4 ways to express z, 4 different forms. It can also be given by factorising that form, but there's no point in writing it down. And now I'm going to show you some uses. So I'm going to first go through some uses which I find of treating it in this form, remembering, of course, that r by e to the I theta is equal to r cos theta plus ir sin theta. Now, if we were to substitute values of theta in for 0 pi or 2 pi, and half pi, pi, or 3/2 pi, and all their other values given by tau, these are the outputs we'd receive. So for 0 or 2 pi, we receive r. For half pi, we'd receive ir. For pi, we'd receive minus r. And for 3/2 pi, we receive minus ir. And this is because if we were to substitute these values of theta in where the theta is in the cos theta and the sin theta, and we are to look at the cos theta, the cos and sine graph, and we were to say, if we pick the half pi one to examine, we take half pi and we see that the cosine is at 0, so the cos term disappears, and the sine term is at 1, so we get ir by 1, so we just get ir. And this is true. I'm not going to go through each of the ones, but you can examine the graph for yourself, and you can see how we get each of these outputs from our function. And finally, a very good way to represent that is by, if we superimpose an Argand diagram and the unit circle, we can see we go 1i minus 1 minus i going round, where this is our imaginary axis, this is our real axis, and we have 2 pi or 0 pi, half pi pi, 3/2 pi going round. And this will give us different values depending on where we have our angles and r's and etc. for our z. Finally, for this video, I'm just going to show you the main real use of why we put them in polar form. We've been going over how we put them in polar form, what's equal to what in polar form, and representing clearly why we get these results. But now we're going to show you what the actual use for polar form is, and there is some real good use to it. If you remember back to some of my first videos, we multiplied some numbers in polar form, we summed some numbers, and we could, even though we didn't earlier, take some numbers to any power we wanted really, 3, 4, 5, 10,000, whatever you want. And what we're going to do is we're going to show you now why polar form is useful. So if I was to give two numbers, z1 equals, say, and we take r to be 5, and we're going to give it in this form here, because this is just easier to write, but of course we're just swapping this side for e to the I, and then adding the theta, and 45 degrees, and we have z2 equals 10, and we have 20 degrees. Now, if we were to multiply these two numbers together, I'll show you how easy that's done. So we do z1, z2, and now they're in polar form. We simply multiply the two magnitudes, so we get 5 by 10, and we sum the two arguments, which are the two angles, so that's 45 and 20. So then this means we get a result of 50 and 65 degrees. I will now also do z1 over z2. So we do z1 over z2. And for this, we do a division for the two magnitudes. So we do 5 over the 10. and here we subtract our angles. Now, remembering with division, obviously multiplication is not a problem, but remember with division to get this the right way around. But that is the one that goes on the bottom, and the Z2 argument is the one that's subtracted from the Z1. Obviously, if we flip this, we flip everything round. So we do our 45 minus our 20. So then this gives us a half, simplifying the fraction, and 25 degrees. And for our final one, we're going to raise Z2, we'll take, to a power. So we'll just do, because we can pick any power, what we'll do is we'll just do Z2 to the n. So this can now be given by, and this is also just to remember, think that Z2 to the n, if it was Z cubed, say, this is equal to Z by Z by Z. So this means we'd multiply all of the magnitudes together, which is the same as doing all the magnitudes to the power of, and we'd sum all of the arguments. So this means we can write this down as 10 to the n, and then we have n by 20. So if we were to give n a value of, say, we'll make n equal 4, then all we do is we do there we go. It's nice and easy. And this is also true if we are to do, if we were to represent this number by e. So Z2 would be R E I theta, which would just be 10 E I 20. And then all we do for that, if we were to say do this to a power, what we would get is we'd represent Z2 like that. Just sub the numbers around. Nice and easy.